All right, what's on the bench? My friend is over here. I've known my friend for 45 years. Yeah. We met at HP back in the old days. He's got this cool DC current source, what I've never ever seen before, and it's got trouble, so we're going to try to fix it today. An HP6177C, and it's got some really nice ranges. It's got a 0 to 5 amp full range, 0 to 50 milliamps, and 0 to 500 milliamps. And it has a compliance voltage, I think this one's 50 volts, yeah. So compliance of 50 volts and 0 to 500 milliamps. And you think, well, it's not just a power supply, constant current, constant voltage power supply. It's actually really designed to do the current thing really, really well. But it will have an over voltage. So it will do sort of constant voltage, but really it's a protection thing. You can use the voltage knob to set the limit. So the way you use these things is that you turn them on and you set whatever max voltage you want. You read the voltage here, you put it on voltage, and you measure whatever voltage you want. So, okay, that's my compliance, so I don't want to go above 30 volts. And then you can go measure amps, and then you can short out the supply and set the current that you want. And then it's set to do that current for you. He says that it blows a fuse, and this knob is really, really tight. So I say before we plug it in, let's open it up. It's dusty.
It's dusty. I purposely didn't dust it off because I thought there might be some clues in colored dust or whatever, because you can see in the inside of the cover there's two blackened areas.
Oh. A hint. Okay, that one makes sense because it gets hot. And that one does not make sense. So something in here doesn't make sense.
Yeah, I looked and I didn't see anything, but you may have sharper eyes.
Well, we can put a thermal camera on it.
Okay.
That's the way to do it. But you say you put a fuse in it, it blows, so we can't turn it on or we can, if we do it a short term. We can short out the fuse and then do a real short term, look for thermal problems, and then turn it back off again. So we could do that, but visual inspection's always good. I love these old diodes. I don't know if you remember the stockroom. The stockroom always had these we used to call them snot diodes.
Yeah. Well, and light would affect, so you could get leakage.
Yeah, they could.
Eventually got rid of them.
I've done a video on that. But I've always loved those diodes. That's the fuse, I guess?
No.
That's
so there's like two halves. I looked at the schematic a little bit. There's two halves of the power supply.
That's right. There's a 1 amp fuse inside.
And in fact, I thought, since this fuse did not blow, it's not in that part of the circuit. It's in the other part of the circuit.
Probably the power supply. All right. Let's open it all. Oops. Let's open it all the way.
Yeah, I had to fiddle with that. You didn't have to take it all the way off, but right, you do have to slide it.
You have to slide it over.
Just the way you're doing it.
Yeah, it's a pain in the butt.
Right, that wasn't a great design.
Nope.
Yeah, you don't have to take it out.
I knew somebody that, oh, you don't? Okay. I knew somebody that actually worked on this series of mechanical engineer. I won't mention his name on camera. Yeah, I guess you don't need these taken off. Anyway, I'll do it later. All right, so my suspicion is that these are the culprits.
Ah, okay.
Okay, and have some replacements.
Oh, look at this!
I went to Anchor Electronics yesterday and got those just in case. Figuring that's what's going to be wrong. Because these are 400 microfarads and 150 volts, so
it's marginal.
Marginal. All right, let's show everybody the schematic. this is what we're looking at. All right. So this is going to look basically like a power supply. There's a bridge rectifier, so you have raw voltage here. There is a path here. This is the plus, here's the minus. So here's the current path here, and then here's the pass transistors that regulate. And then there's some resistors here that you look at the voltage across the resistors, and that senses the current, and this is a feedback path. So you look at the voltage here, and then this feeds back to these guys, and the whole thing self-regulates. So everything's going good there. Here's those big capacitors that we just looked at. So there's two of them here in parallel, so 400 and 400. They're 100 volts though, so they're probably going to go bad, and they are before the fuse. So because they're before the fuse, there's really not much before if blowing the fuses. It's probably these guys. So I say we replace those, just even if they're good, I would replace them. And there's another one over here for this supply, which is completely separate. This is to run the box. This is to run the supply. This is to run the box. You get plus 12, plus 6, plus 5, minus 16. So let's go ahead and replace those and see if our fuse problem goes away. So, need to get that board out of there.
Yeah, I looked at it a little bit.
I still want to get this out of here. I don't like that.
Yeah, I never could get it off. I played with it a while.
You have to flip this down first. Then this comes off. Yeah, there we go.
Oh, good for you. Okay.
And then the bail will come out. Maybe. Theoretically. The side has to come off. Oh, well.
Well, you might have to take a side off anyway to get this board out.
Yeah, we will. That's interesting. Screws are missing.
Oh.
No, it's just riveted in. The standoffs are riveted in. Let me back you guys up. Okay. Yeah, these were called the Series 2 chassis. My friend Paul, he was like straight out of high school or something. I don't remember. He was young. He started working in I think this was done in the Redwood building.
Oh, really? In Palo Alto?
Yeah. And there was the transformer building where they wound transformers. Oh. And then there was another building that did mechanics and stuff. Yes, indeed. The board is right here.
This stuff was so cool to have around back in the day. You could build stuff up with this, erector set chassis and other components that just all fit together and were well designed.
They used to sell them, I think. You could buy...
Yeah.
You could buy chassis parts.
Yeah, all that went away.
Yeah.
I
Okay.
think you're going to have to take the side panel off, get that board out of there.
Maybe.
Well, because it's plugged in.
Oh, you're right, it's plugged in. Okay.
Because I looked at it a little bit. I don't have your skills, but I'm not a complete... Because I sure wouldn't want to bring this around and have it some obvious charge resistor inside. And it's like, you couldn't see that? So I certainly looked at it before. And then it got beyond my abilities. And I thought, okay, let me bring in an expert.
Well, and now everybody can watch it on camera. They can watch both of us be idiots.
No.
Oh, they'll find something, don't worry.
Well, okay, that's fine.
There's always the armchair guys who know better.
Yeah, sure.
Okay.
Now we're cooking with this.
Yes, sir. Interesting. Okay, now we need to unplug it, but that's
in the
Still
way.
not easy, is it?
Yeah, that's,
Why is that not easy?
well, do you think, is there clearance with these?
Yeah.
Will it come through there? And then,
might unplug.
if you need a third hand, let me know. Otherwise, I'll stay out of there.
Oh, I know. There we go. There.
Maybe.
Halfway, it's unplugged. It's
Maybe.
unplugged, but now it's captured.
Yeah.
I guess this board has to come out.
That's unlike HP.
Well,
Can you take?
this went in first and this went in next.
Yeah. Can you take these off from the other side?
No,
Oh no, because it's well, maybe.
they're riveted in.
Oh, it's riveted. Okay.
Yeah, these
this
guys are
this
pressed
side.
into the
Oh,
board.
okay. Okay, I got it.
Board comes out.
Well,
This is one of the better HP designs. It's easy to work on. Oops. Screw in there somewhere. I was at a Keysight event and was talking to an old timer who joined the New Jersey division, the Harrison Lab division.
what do they make?
They built all the power supplies. They probably
I don't
probably designed this product there.
Oh, okay.
They're building. They had a little power supply like this big, like that big,
Yeah.
and it was like 1,250 watts.
Oh, come on.
I looked at, and the fan couldn't. I don't know. The thermals on it were insane. Like, how
Must
could
have had
that?
very good efficiency.
How could they
because,
possibly?
well, I mean, if, it's very efficient. You don't have that much heat to dissipate. But
Yes. Craziness. Craziness. I'm gonna have a good look at the board too, which is good. Oh, you're right.
yeah,
Can you guys see that? Look at all the burn marks. There. I think it's toasty. There's a big power resistor there that's getting toasty. Even these guys are getting warm, so. And it's had rework done. Had an op amp replaced. Had 2 op amps replaced already, so.
okay. This may be.
We'll see. But it was working. You've used it, right?
So, well, I believe so. Okay. So the reason I say that is it's been sitting on the shelf for a while, and I have lots of gear, kind of like you do, and most of it's working, but occasionally something isn't working and it stays there. Anyway, I believe it worked the last time I used it, but
Okay.
it's been on the shelf for a while. So
Okay, let's move everybody here. Let me change my soldering iron tip to a nice big one. And get you guys in frame there.
special tool.
Yep. I've got another good tool. This one. Did I show you this one?
No.
It's got a magnet on it, so if I drop something, I can just.
Oh, and then you even have a plate to put. Keep it out of the way.
You don't know how many stuff. You get old getting off your.
Hey, no, I completely
Okay.
can relate.
Okay, let's get these weird bastards out of there. They have a big mount, 2 big mounting tabs, and a center pin, which we will need to try to all heat up at the same time. Try to remove. These are impossible to get out there. So I kind of wiggle them out. You get one side, then you get the other side. There we go. Keep levering them. There we go. Oh, there's another one. Tricked me. There's another tab.
What? They didn't want those things to come out.
No. Built to last. Now, who's hanging on? There we go. Oh! You see the
Let me see.
goose pushing out?
Yes, I do. Here, you want to
Yeah.
have a good.
Can you guys see that? There's like a little mushroom growing there in the middle where the goo has come out.
Let me see if it's shorted.
Here you go. Let me give you a.
Yeah, I was gonna.
Let me give you an ESR meter. This is really cool.
Didn't think I could get around you without hitting the camera.
It'll tell you what's going on. All right. Let's get some solder on these things.
Well, it says it's got 0.1 ohms across the capacitor.
Oh, that's not bad. Does it say its capacitance value?
Let me just see what happens if I short these two. So if I short these out, I get 0.14 ohms, and if I now measure across the capacitor, I get 0.1 ohms.
Well, that's
Now,
not bad.
Let's see. Let me see if where's the mode here.
That's not bad.
Ohms.
But anyway, it's no good.
Yeah, it only ever gives me an ohm value.
Yeah. Here's a multimeter.
Well, no, this one indicates it's okay. 500 microfarads.
Oh yeah?
And
Wow.
It's marked as 400, so that certainly could be. I mean, these tend to be on the high side if they're anything.
Yeah. My bet's still on something.
Well,
like that.
I mean,
even though it measures 0.1, it might be actually shorted instead of actually an ESR event. Well,
Yeah.
no, I don't know.
Yeah,
I don't know.
yeah. Well, but as you pointed out, this one does have goop coming out of the bottom. I mean,
That's never a good thing.
that's never a good thing, right? Things aren't supposed to leak oil.
Unless it's British. There we go.
Okay.
Capacitors are out. There's another one. One on the floor. Get your way.
Okay, so number 2, the one that was on the floor, has a little bit of goop. And number 1, the last one you took out, or number 3, doesn't have any goop. But let me take a look at it here.
All right. Okay. Okay, these guys are in parallel.
Yeah, this says, again, 490 microfarads.
All right, let me move you guys a bit. Oops.
He's not doing anything. This guy looks the shorted guy. So this guy is 0.07
Oh,
ohms. And let me short these probes out and see what I get. Yeah, I get 0.05 if I just short the probes.
okay. So you got one
So-
shorted cap.
One shorted cap. You called it.
Okay.
Yep. Yeah, it both has by far the lowest resistance, and it won't do anything on the capacitor scale. So
Yeah.
this is the toast guy. Man, I'm impressed.
Okay.
You absolutely called it. My very uneducated guess was it was one of the diodes in the bridge circuit in the power supply.
I don't know how many times I've suspected diodes and it never is.
Well, again, you've got more experience than I do.
Okay. All right. So I had guessed ahead of time, and I bought capacitors at the store.
I am so impressed. Oh, gosh. I mean, the fact that you even, I sent the manual along, but I didn't really expect you to go through the circuit ahead of time.
I did.
Well,
Because I knew the store wouldn't be open today.
again, I'm just super impressed with the whole.
All right. So we got us. I love showing this off. Yeah, these are 400 microfarads and 150 working volts, and the manual says 100 volts.
Well, they may have already had trouble. And
That could be. These are 100 volts, so let's hope these don't blow. I think this will be fine. These will be fine. For this particular unit, there was 2 units built. One of them had a voltage doubler in it, and it was a 100-volt unit. This is the 50-volt unit.
okay.
So that's probably why they said, well, just use the same capacitor everywhere or something. These should be fine. Okay, so these go like that. That's a big hole for, for a little lead. Our little lead now. Okay, we'll bend this guy over all the way there. All right. Oops. And that looks good. So one of the HP stockrooms had followed through a couple companies. It was HP, then I think it was Avago, and then I think it was, I don't know if it changed names, but it was eventually became part of Broadcom. It was the fiber optic group. And that stockroom, they'd finally gone through it and said, we don't need this stuff anymore, and they threw it in the trash bin. And my friend's always looking at the trash bin, and they got rid of all of the old 7000 series CMOS because nobody uses it, right? So I got a big bag of 4000 series CMOS out of the old stockroom.
Well, yeah, the stockroom was great. The whole thing about working at HP back in the day was just super.
Okay, that's interesting. So these capacitors have 3 mounting tabs, right?
Right.
This one are all for mechanical reasons, and they're also the negative
Right.
the negative contact. But on the PC board,
They're not connected.
no. Well, on this particular one, they're using the capacitor as one of the traces on the board. These 2 guys are...
Boy, good catch. You're going to have to short it with a jumper.
These...
Wow. Yes, good catch.
And that one as well. And that one as well. So we have to put some jumpers on.
Boy,
okay.
Good catch.
All right. All right. So let's go ahead and put this one in here because I can. I guess I could have done that. That was dumb. I should have done it with all of them. Oh, that's better. Doesn't matter.
Oh, you can use the wire from the capacitor itself to do the jumper.
Probably could. Does it reach? It does reach. That's kind of cool. Okay. This one here is not connected to anything. This one is. This one needs a jumper as well. I just so happen to have a piece of wire here. Alright. And hole up. Oops. All right. Okie dokie, we're good to go. All new capacitors. Remember how to put it back together?
Is it worth checking if the diodes are shorted on there?
Oh, we could do that. Where's that meter I gave you? Let's go ahead and use this thing. It's already ready to go. We should get a beep if they're good. There you go. Blue. There you go. Yep, 0.5 volts. They're all good.
Good.
Oh, maybe I didn't test that one. Yeah, they're fine. These guys are instructable. Globus not diodes. And these capacitors here are indestructible. So I think we're good to go to reinstall.
Okay.
So the board though does look hot, but maybe functional. I mean, a lot of these old power supply boards just got blazingly hot. It's 500 volts at half, so it's 250 watts, right? No, 50.
No, not 500 volts.
25 watts.
50, yeah.
25 watts.
Half.
And efficiency and stuff, there's probably stuff that's running that hot as well.
It doesn't seem like 25 watts. I mean, if you think about like a 25 watt light bulb.
So light bulbs, so it's deceiving. Light bulbs have this glass enclosure, and they're insulated. But a 25 watt resistor, they get hot.
That's a very good point.
They get really hot.
You know, when they first started making the LED filament lamps,
Yeah.
they were filled with helium.
What?
Well, so the reason was they needed to get thermal conducting heat away from the LEDs.
Yeah.
And so if there's vacuum inside, there's basically an insulator around.
Oh.
And so they picked an element with the highest velocity, so they picked helium. I mean, this was really, eventually the efficiency got good enough they didn't need to do that, but the better of the filament lamps were filled with helium.
Wow. That's wild.
Pretty sure Osram came up with that.
Yeah.
At least that's who told me originally, was an Osram guy. Now, I did have the opportunity to get to all of the major lighting design centers, so GE, Philips, and Osram. And the interesting thing, they were all beautiful. I mean, it just had wonderful things with light and history and so forth. But another interesting thing was they all claimed to have invented everything, and the other people copied their stuff. It was just hilarious. The first time I heard it, I was, eh. The second one, same story. We invented everything those other guys copied.
All right. Make sure I got all these. Got that one. Oh, this one. That one. That one. That one. I'm not missing. Oh, there's one I'm missing. Okay. Oh, it's the screw that went inside the machine that I never got out.
Oh.
There it is.
Hear it, yeah. Boy, good memory, yeah. I remember it dropping, but then I promptly forgot about it till you just mentioned it.
Okay. There we go. Put this connector on. This big connector over here. Oops, this way. And our PC board plugs on there now. Put the slide back on. These guys got little notches that they go in. There we go.
Now, do you think these chassis were designed on a CAD system or a drafting board?
No.
Drafting board, really?
Yeah.
Wow,
Yeah.
wow.
I don't think ME10 was around yet.
Oh, ME10 would have been around. I didn't know if there was a predecessor, maybe.
I don't think so. I think ME10 was like the first CAD program they ever used.
I mean, when would have these been designed? Like early 70s? Or when was...
Yeah, that's probably a guess. I don't remember when the Series 2 came out.
Okay. It's not that big a deal. But I remember being just, I don't know, in awe of the stuff that HP had. Like, besides these chassis, like whatever transformer
Yeah.
you wanted, you specified blah blah blah, and right, you
Yeah.
set it in an order, and boop, custom transformer.
I'll catch some flack, but it's my experience that Textronics had some really, really good electrical engineers. But I would say the mechanical engineers were not up to snuff against HP mechanical engineers.
Really?
Yeah, I think the HP mechanical guys were better. The Tektronix guys made some really goofy, kind of, more clever than they're worth type designs.
Well, it may have been a case where they didn't really, they didn't always have a mechanical engineer when they needed one. And so, well, you're an engineer, you can, and you can design cross things, but generally not as well.
I don't remember putting. Oh well, maybe I did. Come on.
I think once in a while you get a really good crossover, where they originally were trained in one area of engineering and then and were good at that. And
Yeah.
then for whatever reason got into another one and got good at that. And so
Yeah.
now they've that's a rarity, but they're really useful people.
I knew somebody at Labs that did thermal engineering, which, but like heatsink engineering. And I think he was a mechanical engineer. I think he was one of those guys that kind of crossed over. He just like, hey, you do it, and I think he had to learn it. And then he just kind of became the expert. He worked on, this is way, way a long time ago, but Pentium fans. He redesigned the fan so that it was cutting at a perpendicular angle to the airflow always, and
Okay.
to reduce the noise.
Oh.
It's like, oh, geez. That's pretty smart. Okay. So I think we can try powering this thing up again.
Okay, you got a fuse.
I'll have to find one.
1 amp is the
1 amp. Pro. Preferred one?
Well, that's what was in
What's
there.
the book says? Yeah.
Yeah, I mean, that's what it says. It's kind of standard blow.
It wasn't slow blow?
No, well, okay, the one I took out was not slow blow. Blow. And it didn't say on there.
Oh man, this first one come out. Shoot. No. If there's no fuse in there, you took the fuse out?
Yeah.
Yeah, if there's no fuse in there, then
Right. I should have left it in for exactly that reason. For exactly that reason. I thought no sense leaving a dead
there's a
fuse.
hole in the
But
back.
there was a good reason for leaving a dead fuse in there.
Open that drawer there. There's some copper wire. There you go. We will snake it. Okay, good. Now I can push on it. Maybe. There it goes.
There you go. Jeez.
Roto-rooter.
Good job. Good show.
All right, so okay, I need to go find some fuses here. I did get organized once.
Oh, wow. Okay.
I remember I got organized once. I bought these off of AliExpress
Yeah,
or something.
and that's simpler than organizing the other
right.
you already have.
Now people say, don't ever get your fuses on AliExpress because they'll be 10 times the value that's stamped on them. Like, oh, whatever, dude. It's like, yeah, you're probably right, but you know, you pay as your money, you take your chances. Well, that's interesting. 1 amp. Okay, this one says 1 amp right on it.
Okay.
Yeah, seeing is believing.
Well, I don't know. I'm not sure that's...
That's funny. You know the phrase, there's a sucker born every minute?
Yes.
Do you know that's not the entire phrase?
No.
There's
What
a
is
second
the-
part of the phrase.
Which is?
And there's 2 to take his money.
Oh. Yeah.
Yeah.
That follows.
Sucker born every minute and 2 to take it. Yeah. Okay.
Okay.
Dun, 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 dun. Let's see, screwdrivers. What I'm going to do, I'm going to turn on a thermal camera while we're here,
Ah, good thinking. Yep.
in case something starts to go wacky.
Well, even if it doesn't, it's still worth looking because
Yeah.
we do know of those 2 areas that are obviously getting hot.
Yep. All right, let's plug it in.
Well, you might want to check before you plug it in if it's in the off. Oh, it's in the on
Oh,
position.
yep, it's in the
That's
on
okay.
position.
But it's not humming like it was before. So when I turned on, you know, you could hear the transformer plates vibrating.
Ooh, looks like it's on.
Yeah, it's definitely on.
Volts. Voltage knob. Volts is sort of working. I don't know.
Well, it says on limit, so I wonder if the current is not. So it's limiting. It's almost.
Yeah, it's limiting. It's limiting because it's too high. So what we need to do. It's functioning correctly.
Oh, good. Okay.
Yeah, it's functioning correctly. Uh-oh, I do smell something getting hot. So let's take a look. Oh, we got this guy. Super hot there. Wow. What's something non-conductive to point with? That thing. Yeah, see these guys, those little diodes in there?
Yeah.
Those guys are just smoking hot. Wow. Where's the power switch?
It's this guy right here.
Ah, that's why. Okay. Yeah, those guys are just smoking in there. And that is, I think, a Zener diode. Because it says VR. It's probably a Zener diode just cooking in there. If you have any diodes that die in instruments, it's usually the Zeners.
Well, yeah, they're operated reverse bias,
Yeah.
so you're constantly
But it
breaking
is
them down.
doing something right now. And it may have been doing that forever. We don't know.
Right, that's true. That's true.
We don't know. It might have been doing that forever. Okay, so let's
Well, let's see if we can put something
Let's
across
play with it
to
for a
see if
bit, just to see if it does
it'll
something.
regulate at all.
okay. Let's
Put an LED.
yeah, let's see here. Let's go to test leads. Minus and plus. And we'll put it on the 5 milliamp range for starts. And ooh. Uh-oh. That's not right.
Well,
It's pegged on max current.
well, and that may be why this is limiting all the time, because if it is trying to, it's running up against the voltage limit.
Oh, maybe.
Wow. Looks like a lot more than 5 milliamps.
Yeah. I don't think it's healthy. I don't think it's healthy.
Yeah, I agree. Something else is... That may have been a cascading effect. Something failed, and then that caused something else to fail, and then...
It could be.
Where is there any other place besides here that did, like, is this area hot? Did we?
We didn't really look around. Let me get a better camera. This is not the greatest camera.
Most guys don't even have a camera. You've got multiple. Jeez.
This is my best camera. It's a pain in the ass to use, but it's a better camera. My old phone was Lightning connector, and my new phone is a USB-C. Apple changed over because Europe made
right.
them.
Well, as consumers, I'm glad.
Yeah, I like it too. Lightning connectors were a pain in the butt. Okay. Yeah, so now we got all kinds. Okay, so that resistor right there is getting toasty, but it's okay because he's supposed to get toasty.
Right, he's a big resistor.
He's a
right.
big resistor.
10
Okay,
watt or
I feel
something.
better about him.
Okay,
Well, let's
but
go.
that, yeah, that. Well, now we
we got another toasty one in the back, but
But
he's
that's
supposed
that
to be
big
toasty.
resistor, right?
Yeah.
It's these two little guys in between here.
Yeah, so let's
that
turn
are-
it back on. Okay, that's weird. Yeah,
Yeah, you can see it right away.
that looks
Check
like
exactly
that
which
looks like
one
it's
it is.
hot.
Now, what's this other thing that's getting hot over here? This guy. Oh, that's this guy,
Yeah.
I think.
No,
No?
it's the resistor next to two. There's two. Oh, that's over here. Yeah, it's one of those guys down there. But he's
Okay.
okay. He's not very hot. He's not very hot.
Yeah,
That's
yeah,
okay.
okay.
That's okay. That's okay. I think. And there's a big resistor under there, but he's supposed to get hot.
Yeah, but it's this guy up here that's... Where'd he go?
But he's not hot anymore. Those little
Yeah.
tiny guys are
Yeah.
not hot anymore. And I don't know why.
Yeah.
And I don't know why.
Yeah, wow, it pegs as soon as you...
Oh, there it goes. Now it got hot when we drew current. And it really drew a lot of current. That was not 5 milliamps. There was no way that was 5 milliamps. Because no matter what,
Right.
it should only draw 5 milliamps, right?
Right.
And it's just going nuts.
It's pegging, right. Yeah, something else is
Yeah,
clearly
so something's not
broken.
in regulation. Okay. Well, fixed one problem, another problem somewhere else. Somewhere else. All
Well, you
right.
absolutely called the initial thing, which was short. I mean, you
that was
figured
easy.
out exactly
That was easy.
to the right. With my minimal description of the problem, you jumped to the schematic. There, oh, I think it's these guys, and yep, I'll go buy some. Yep, well, sure enough.
Okay, so let's turn this off. All right, well, we replaced the capacitors, and that was a good thing. They needed it. And it doesn't blow fuses anymore. Unfortunately, it doesn't work, and we've learned a lot. So it's been about 2 hours off camera, maybe 4 hours off camera. It's been a long time. Let me tell you where we are, and we're kind of at a roadblock. Maybe somebody can chime in if they own one of these things. It powered up, but it didn't work. And so I said, okay, let's go back to basics. Let's go ahead and measure the voltages on the power supplies. And it's kind of blowing out on the camera, isn't it? Okay, so measure these voltages here. And I saw no voltages. And I saw, well, first of all, I couldn't find any test points. So I had to start looking around for how do I find test points. And there are some Zener diodes that generate voltages. So like there's a 5.6 Zener that generates that one. There's a 6.2 Zener that gets doubled and generates the 12.4. There's a Zener down here that's a 16.2 that generates the minus 16.2. I thought, okay, I can just measure across those Zener diodes, and those are my test points. So I measured across a couple of the Zener diodes, and I was getting no voltages that made any sense at all. They were way too small, made no sense at all. So then I started looking around, and we poked and we prodded, and we did some thermal imaging and a bunch of other stuff. And so then I started saying, okay, well, maybe there's some other things that are bad. So took out some Zener diodes and monitored their voltages. They looked okay. And then I went to look for VR4. Was it VR3? It was this one here, VR3. I went to look for VR3. So VR3 is this 6.2 volt one. The 6.2 volt one that generates the 12.4. And I looked at the circuit board, and there was no diode on the circuit board. Somebody had removed it at some point in the past. So I believe that this particular unit was a backup unit and had never been put in surface ever before, which means we really don't know what's wrong with it. So I found a Zener diode and put it in, and it quickly got too hot and blew up. So then I found a really big stout one and put the stout one in there, and he gets hot, but he doesn't blow up. And it still doesn't work. I still don't get any of the right voltages. And then if you look at the schematic, let me zoom you guys down here. All right, here's our VR6 for the 16.2 volts, negative. And here's that 6.2 volt one that I replaced. Here's a 5.6 one. I went and I was probing around on the 6.2, and there's a common return. I'm not going to call it ground because that just messes your brain up if you think of it as a ground. It's common return, and in fact, they use the language on the PC board, on the schematic. They use the word common, which is good because it's not a ground. It's just a common node. And that common node is used in the power supply as well as here. This is a common node signia. And you can see that the cathode of VR6 is connected to the common, and that the anode of the VR3 is connected to the common. So that doesn't seem to be true. It seems to be that the anode is connected to the common, but the cathode does not connect to the common in our particular board. And I looked and I looked and I looked, and I tried to maybe find a cracked trace, and I couldn't. I did find a trace that had been repaired, I think maybe even at the factory, we found a trace buried deep in the instrument that looked like it had been repaired. So boards of this vintage did have a lot of problems with cracked traces. In fact, Hewlett-Packard designed an instrument specifically for finding breaks in traces. These days, you never worry about it. They're all tested. They're all good. But back in the day, they were troublesome. So, as a last resort, I put a wire jumping these two together, and then the machine just crowbarred and it didn't do anything at all. I took that out. So it would seem as though either we have a revision. Look, I don't know if this is the revision number, it's revision E, or if that's revision F, or those things don't mean anything at all. And I don't know what the revision number of the schematic is. All I know is that I'm at wit's end and I can't put it together. Humpty Dumpty is not going back together. Anyway, there you go. Hope you enjoyed that.